Good afternoon, ladies and gentlemen. So we continue with NFA DFA. And I remember last week, Tuesday tutorials, we did 1A, 2A, and we started off with 2A, 2B as well. Then on last Thursday lecture, we discussed about question 3, right? Thursday's lecture. Sorry. Okay. Strings or digits. Okay. I'm sorry. Okay. We did strings or digits 0 to 9, which are 5 left, 5 or less. We just did that. That's all. Yeah. Because I was explaining, because the other batch on Wednesday probably existed, so I was discussing again the example problem, and then we just did question for 5. Okay. So for you guys, last Tuesday we have done this 1A, 2A, and I just explained what is this language specification, and some of you have done this, very few of you. So if you have done this, can I quickly check and then go to question number 3? Then we are done. Because 3B is an assignment task. 3C is also assignment task. I will explain how to go about it. So anyone has tried 1B? I remember we had some discussion. Some of you showed me the answer for 1B. I still remember that. So 1B says strings over the digits 0 to 9, meaning the alphabet set is 0 to 9. You have 10 alphabets. Okay, the decimal digits are the alphabets, and which contain 777 somewhere in the string. Anyone would like to share the answer? 1B, yeah. It should take 777 somewhere in the string. Yeah. Even. All right. So what the specification says is, I mean, what you have to do is you have to force the somebody write that. Just write 1B enough. So you have to force the machine to go through 777. That's all. That's the first thought. First thought is force the machine to go through 777, and then like fill in the blanks, improvise on it.
This can be 7 first. Yeah, this can be 7 as well. This actually is 7. Does anyone have a?
Come. I think your answers. Yes, but there's nothing. Because you cannot have a 7 here. That's why I stopped you. It's okay, no worries. Let's give opportunity to others as well. Thanks. To me, that's all. That's why I said the first thought is you have to force the machine to go through 777. Okay. So next, very good. Very good. I want every one of you to volunteer now. And so the thought is, if you see here, it is 777. I explained these are similar but not the same. Here it says 3 ones. 3 ones means not 111, like here 777. 3 ones means 3 number of ones. Okay, as far as minimum, you have 3 number of ones. 3 times 1 somewhere in the string, it is valid. But here, you should have a 777. Okay, which contain 777 somewhere in the string. So there should be at least 1 777. So they are together. Okay, and to me, this is the only thought. There is no other thought. Okay, this is the only thought because certain problems you may have more than one solution. Okay. So why I am saying there is no other thought, you need to have a 777. That's why I said when you start, the first, to me, I visualize like this. You see, this is construction, you are constructing a machine. Okay? You are not a magician. Then the whole machine appears before you know. I always say this in class, like Rome. We say Rome was not built in one day. I mean, the old saying. Okay? Even you build a house, how rich you are, you can construct it very fast, but not overnight. Okay, you can construct it very fast, but not overnight. You have to put the foundation and then, layer by layer, the building is built. So similarly here, my first thought will be like this. So why I am thinking like this means I am forcing the machine to go through 777. This is the final state. So I am forcing the machine to go through 777. So 777 is my smallest possible valid string. Okay. So can I have many 777? Yes. Okay. So I may have some number like this: 0, 1, 2, 3, 4, 777, 8, 9, 7. 8, 9, 7, 7, 6, 5, 4, 3, 2, 1, 7, 7, 7. I'm just giving one big number. 2, 6 and 3. Okay, social arts. arts and music. Maybe programming has okay? You see, that's a big number. It's a valid string, you know. You get me? So if we do this number, what happens? Don't forget this is an NFA. There will be many paths. Certain path will work, certain path will not work. Okay? Certain path will work, certain path will not work. As far as there is at least one path, one route that leads to success, the mission is correct. Okay? When I say this, you should not misunderstand. Okay? What I'm saying is, there may be many paths, it's an NFA. There may be many paths. Some path may work, some path may not work. But at least there is one path that leads to success, the mission is correct. Okay? But this does not mean the machine can accept invalid strings. Cannot. Okay? NFA cannot accept invalid string. Not even one invalid string. Okay? So if I want to give this, actually I will show you one path that will lead to failure. I can loop it here. 0 to 9, that's what he showed. Okay, this itself makes this machine an NFA because I have a 7 here, I also have a 7 here. Right? So the machine can actually halt here, you know. The whole string can be processed here. 0, 1, 2, 3, 4, 7, 7, 8, 9, 7, 8, 9, 7, 7, 6, 5, 4, 3, 2, 1, 7, 7, 7. It can halt here. Halt and reject, but this is a valid string. So what should happen for this string? There are again many possibilities for success. One possibility for success is it goes through 0, 1, 2, 3, 4, 7, 8, 9, 7, 8, 9, 7, 7, 6, 5, 4, 3, 2, 1. First 7, second 7, third 7 for this 7. This is one path. I need to have a closure here as well. Okay, if I have this, I can even do like this 0, 1, 2, 3, 4 for this 7. First 7, second 7, third 7, and the remaining part of the string can be processed here. This is another possibility. Okay, so for a valid string, for an NFA, there may be many possibilities. Some possibility will work, some possibility will not work. As far as there is at least one, minimum one possibility that leads to success is correct. So this is an NFA. So very fast this can be converted to a DFA. Okay? We have to remove the duplicate 7 here. Correct, right? We cannot remove the 7 here because if you remove the 7 here, we cannot go from here to here. Okay? So we have to remove the 7 here. So what we do, we just put 0 to 0, 2 dash 9. So anyone else who have done would like to fill the blanks? Anyone? Sorry, I made a mistake. Sorry, thanks for pointing out. This is 0 to 6, 8 to 9. 7 should be actually not 1. Yeah. Please point out, because here there is always a traffic because of multitasking. So when I'm doing here, there will be many thoughts, oh, I need to do this, I need to do that. A lot of pending tasks will be here. So I may make a lot of mistakes like this. If you see, please alert me to check. Okay? Yeah. Not the one, the 7 should be removed because 7 is duplicate. Okay. Someone want to fill up? I don't know. Someone want to fill up? Yeah. Okay.
One second.
Is that right? Is that right?
Yes, because look,
so if it is not right, why it is not right?
Because you're not going to make it 777.
Yes, that's what I said in NFA. You have to have the 777 together. If you loop like this, you're cutting on the 7. This will accept invalid string. 0, just one invalid string. 0, 7, 1, 7, 2, 7. Invalid string. You have 3 number of 7, not 777. Okay, this will accept many invalid strings. Okay, this will also accept valid string. You can actually run this here. You can actually run this here. Run this here, cannot. You cannot run this here because you have already removed the 7 here. For this 7, the machine will come here. Okay, and for this 7, see, if you want to trace this, those who are still having heart attack don't understand this. 0, 1, 0, 1, 2, 3, 4. For this 7, there is no path here. There is no choice. You come here, 7. Again, for this 7, there is no path here. You have to go here. For this 7. This 7, again, there is no path here. You have to go here. No choice, this 7. So, when you want to process 8, the machine is already here. Correct, right? So, 9, 7, 8, 9, 7, 7. I mean, it can be processed. It accepts valid string. Right, this valid string. Okay. So, see, this is how you will know. Unless you trace it, you cannot simply stare at it and decide whether it works or not. You have to try. Run the machine and see. That's what we mean by realizing it, implementing it and seeing it. Okay, just trace it and see whether it works or not. So when we trace it, we see it works. And it works for valid string, it also works for invalid string. As I said, NFA cannot even accept one invalid string. Should not accept even one invalid string. Alright? So what we should do? We should not break this 777. But we need to have 1, 7, 2, 7 and all that. Okay? Here we have 1, 7, we have 2, 7 and we have 777. Anyone else want to try? Yeah. Okay. So we cannot loop like this. This will break the 777. Maybe I'll remove this because loop back you may not have much space. That's all. No need to suddenly see. You should think and do, not simply, I went in this direction, I will go in this direction. Okay? So why I am saying this is, I know some of you will have this thought. Hey, I looped back here, I looped back here, I also loop back here. So, if you are looping back here, then you are not conscious of what you are doing. Because you already have a 0 to 9, why you want to loop back here? Correct, right? Correct, right? So why you want to loop this? Any one of you? Don't worry whether you are looping it here or looping it here. Why you want to have an outgoing arrow here for 0 to 6, 8 to 9? Why? This is why before you come here, you should read and come. Okay? If you don't read or you don't remember, you may not be able to follow. There are two conditions here. Every state must have an outgoing arrow for every input alphabet. So, Q0 has an outgoing arrow for 0 to 6, 7, 8 to 9. But Q1 has an outgoing arrow for 7, no outgoing arrow for 0 to 6, 8, 9. So, our question comes, should I loop it to the previous state or I should loop it to itself? If I loop it to itself, this 777 gets broken. Okay, so I cannot loop it to itself, I have to loop it here. Right, if I loop it here, I can have a number like this one no. For example, I can have a valid string like this. I'm just stopping here. 1, no choice. 2, no choice. 3, no choice. 4, no choice. 7, no choice. When it comes to 8, he comes back here. 8, 9, 7, 7. You are here. Okay? And what happens if I again have something like this 6, 5, 9, 7, 7, 8, 9, 5, 4. So for this 7, he are here. 6 means he goes here. 6, 5, 9, first 7, second 7, 8, 9, 5, 4. It comes here. What's wrong with this string? It takes so long to answer this. No triple 7. Okay, so if there's no triple 7, it will end up here or here or here. We don't know. It depends on the string. Okay, so only when you have a triple 7, it becomes a valid string. So now we halt it here, right, for this 4. Now if you have a triple 7, first 7, second 7, third 7, all the 7. You need not halt here. After this, again, you may have some digits 0, 1, 2, 3, 1, 7, 2, 7, 3, 7. Okay? Yeah. You understand? So this is a deal. So, as guys, as we keep telling you, you need to practice. What we discuss in class alone is not enough. Okay? So if you observe, each of you sitting for 1 hour of tutorial and 1 hour of lecture. So in 14 weeks, you are sitting into 28 hours. 28 hours, you cannot become an expert. Okay, you need to practice more. Okay? Yeah. Right. So to me, you need not solve 101 problems. Actually, there are exercise questions given in my class. You can attempt to solve it. Okay? And you can, how to check whether your answer is right or not, you just run through the question and see. Okay? Run through a couple of valid strings, run through a couple of invalid strings. Valid string you should work, invalid string you should reject. Okay? And that's how you learn. Okay? Now that's one good thing with this subject. I don't need to go and ask my teacher whether my answer is right or not. I can verify myself. Okay? If the machine runs, it works, that's all. Okay? Easy enough. Yeah? Alright. Let's move on to next. It's 11:30, 12:30. 1C now. 1C, the thought is opposite to 1B. Strings over digit 0 to 9, up to here the same. Here it says which contain 777 somewhere the string. Here the thought is which do not contain 777 anywhere in the string. Okay. So there are, to me, there are two different thoughts. Okay. I can still mimic this. Mimic this means I can try to follow this thought. Okay. But here the thought is if it's 777, it goes here. Correct, right? Make a small tweak. You have the answer for 1C. You make a small tweak with this answer. You already have the answer for 1C. Yeah, anyone else except for these two guys? Because I want others to, yeah. Check out the last final state and then. That is the final state. So you remove this final state, okay? That's right. This is final state. That's all. So the question says only 777 is wrong. We can have 1 7, we can have 2 7s. We can have 0 7s also. So here you see, you have to understand, read this, see, you have to, this is in any language. Okay? Not everything will be explicitly said. Okay? Not everything will be explicitly said, that is not a problem. Okay? Here, there are many hidden messages. How to understand them? By reading this repeatedly. In English, we say beautifully, reading through the lines. Okay? Reading through the lines. Okay? What this question says is, the strings are made up of 0 to 9. Okay? So the strings can be made up of any of the digits 0 to 9. Okay? Only invalid string is if it has a 777. So I can have a number without any 7 at all. I can have a number which has many single 7. I can have a number which has many double 7. But I should not see even a single 777. That's all. You get me? You understand me what I am saying? Perfectly valid. Just 1 7. Okay? I can have 7, 7, perfectly valid. Okay? I can have a number like this 0, 1, 2, 3, 4, 5, 6, 8, 9. I can have a number like this, no 7 at all, perfectly valid. You get me? Yeah. I can have a number infinitely long. I have a number infinitely long, but if you observe, I have many double 7, many single 7, but there is no single triple 7. You understand me? Yeah. This is what problem solving is. Okay, problem solving, you have to think critically, analyze critically, understand the problem, and then solve it. Okay? If everything is explained there, then it is not a problem. Then it is not problem solving. Okay? Do you understand me? Yeah. So now you can solve it. Actually, she gave the answer. Right? You just need to just fine tune it. That's all. She's almost. She's there. She's there already. Yeah. Sorry, come again. Ask yourself. I have given valid strings. Just try and see. See how you learn means. Don't get me wrong. If I'm not answering your question, I want. This is what I say. Inquisitive mind. Inquisitive means inquiry based, not enquiry. Inquiry. Inquiry means asking yourself. Can I put Q1 as final state? How to know that? Go and try. Okay, if I give 7 as input, I have said 7 is a valid string. Okay, don't forget that is a DFA. That is a DFA for 1B. We are doing NFA for 1C. Okay. No harm. You can look at the DFA for 1C also. No harm. Okay. So what happens if I give 1 7? What happens if I give 2 7? The machine should accept. Okay? Yeah. So let us do the NFA first, because NFA is easier. There is no restrictions. As far as it works, it works. So I have to be very conscious of time because we think for 1 hour. You want to try? Don't worry, I will help you. Hey, don't be shy or afraid. Yeah. I'm here to help you. Okay. See, my voice is loud because I'm not this generation. I'm a bit, Yeah. So those days, luckily, even in this Taylor's University, we had whiteboard. Today we have a microphone and all that in every classroom. Every classroom we have a projector. Those days, no, Okay, so you have to shout. Okay, for the entire class to hear. Otherwise, can you repeat? I couldn't hear you. So I have to be very loud. So keeping shouting for 30 years. Now, any of you from Taylor's College? Then you should have had my friend Lee Venkat. He speaks like a whisper. I always tell this. I tell him also, when he speaks to me, I also whisper. I tend to speak to him like this because he's like that, very soft. Okay? Yeah. So he cannot be loud. I cannot be like him. Right? I can pretend to be like him, very soft, only for a short time. Okay? Yeah. So don't take my voice, to be rude or something. Okay? I'm used to it. So feel free. And we are here to help you to learn. Okay? Don't be shy. If you're wrong, doesn't matter. It's not a crime. You're still learning. Okay, I want you guys to tell me, is this correct? This is what we mean by criticism. Criticism is not to find fault. Criticism is to argue. Argue means not the fight argument. Oh, no, I need coffee. No, I need, that, not that argument, fighting argument. The argument here is what is right, what is wrong. Conversation, discussion. Okay, the scientific community, we call this as argument, not the fighting argument. Okay, the argument is what is right, what is wrong. So if it is wrong, what is wrong, why it is wrong. So by saying what is wrong, why it is wrong, we call it as constructive criticism. Constructive criticism means it helps to improvise the answer. It's not about fighting for it. Okay? So nothing wrong to say that is wrong. Only thing is you should say, if you say this is wrong, you should say why it is wrong. Okay? So is this right? Is this right? Is this right? No. Why? Why is not wrong? Something should prompt you, right? It is not wrong. Yeah.
Yeah, it doesn't really end any time.
1, 7 it works. Double 7 also it works. 0, 1, 2, 3, 4, 5, 6, 8, 9. 0, that third example there. 0, 1, 2, 3, 4, 5, 6, 8, 9 also works. Yeah, we are doing 1C, everything. 1C, we are doing 1C, NFA. That's why I'm asking you, is it right or wrong? Guys, if I just want to give you the answer and tell you this is right, I can finish the tutorial, whole tutorial in 1 hour. Okay, that is not my intention to cover the syllabus. I want you guys to learn. That's why I'm asking you. If you ask me this is right or wrong, I can tell you the answer. Yeah.
You should be right.
Not should be right. It is right. Yes, it's right. No, it's wrong. Yes or no. Deterministic. Decidable. Desirability.
Looks right.
This is right. Okay. Yes. So this table, let me go by table, let me go by island. This island. Is it right or wrong? Yes. Is it NFA? Okay, it's a good question. Every semester students will have this question, at least a few of them. Can I just draw a DFA and say it's an NFA?
No.
Theoretically, yes, because DFA is a subset of NFA. But here the question is for you to draw an NFA. So you should draw an NFA. Okay, and question number 2 says construct or convert the NFA into a DFA. Right? So if you just give this as a DFA, actually this is DFA now. It's not wrong, but it's not an NFA. Why is it DFA? Every state has an outgoing arrow for every input alphabet. 0 to 6, 7, 8, 9. There is no duplicate. Correct, right? 0 to 6, 7, 8, 9. No duplicate. 0 to 6, 8 to 9. 0 to 6, 8 to 9. That's what I want you guys to tell me. Oh, sir, it's NFA. 7 is missing in 7. So 7 is missing in state C. Why are you not saying that? When I say the DFA, an NFA. Okay? This shows that either you are afraid or you are not confident. So that's the level. Oh, this is an NFA because state C has no outgoing arrow for 7. It appears to be like a DFA. Correct, right? Correct, right? Yes. So it's a perfect answer. Okay, and you can see there is only opportunity for 1/7. You see how this is a thought process. Huh? You can have 1/7. There's an opportunity, and then you can have 2/7. Okay, you cannot have 777. Correct, right? Okay. So you make a small tweak here, it becomes a DFA. And that's the thought. That's what she was saying earlier. Just remove the final state here and make the other states as a final state. It becomes an NFA. Okay. Actually, in this question, you had another state here, right? So that you can have a 777. These were non-final state. This was a final state. Correct, right? It was like this earlier. For 1B. Correct, right? So it has been just removed, that's all. We just made a tweak. Actually, most innovations in the world are minor tweaks to the earlier versions. Not 100% out of the box. I'm not saying all. Most of the inventions. No, not inventions, innovations or innovations. Most of the, I'm not saying all that. Majority of the innovations, they are improvements or tweaks to earlier innovations. When it becomes a new innovation. Okay. So this is a similar, it's very similar to earlier solution. But now if you want to have a DFA, what we need to do? So what makes this as an NFA? Outgoing arrow for 7 is missing here, right? Just put that. You can call it as error state. I'm giving you now a new thought. Not necessarily it has to be called as error state. You can simply label it as D because she has labeled as ABC. You can label it as D. Okay? And since this state is also a state, okay, you need to have outgoing arrow for all the input alphabets 0 to 9. Okay? It does not make any difference. Why? I'm not calling this as error state, I'm just calling it as D. If I land here, what happens? If I land here, halt and reject, right? Halt and reject, right? If you give a 777, first 7, second 7, third 7, halts here. A machine should halt only at the final state. It cannot halt at the non-final state. If it halts at a non-final state, it is called as halt and reject. So if the machine halts here, it is halt and reject. Okay? So whether I label it as error state or I simply call like this does not matter. You understand? Yeah, does not matter. Ask yourself. Where is 27 errors here? That's why you shouldn't rush asking question. Where is 27 here? You have only one. You see, this actually means 0, 1, 2, 3 like this. But it becomes very cluttery if you have to put 10 arrows like this. Okay? That's why what we do is we simply say we put only one arrow, but we say this arrow is for all the digits 0 to 9. There is only one 7 here. There is no 2 7. If you remove 7 here, it again becomes an NFA. You get me? Everyone? Yeah. That's why I said, you learn by asking yourself, if I remove 7, what happens? You should ask yourself, if I remove 7, what happens? Am I satisfying the two conditions? If I remove the 2 7s here, am I satisfying the two conditions? No. Because just now I told you, whether I call it as error state or simply D, this state is also a state. So every state, whether it is error state or start state or intermediate state in a DFA, every state must have an outgoing arrow for every input alphabet. Read this question, read this point many times. Every state. It does not say start state or intermediate state or other state. It just says every state. Every state must have an outgoing arrow for every input alphabet. So this state is not a final state. Okay, I'm telling you again, if the machine stops here, it is called and rejected. You can call it as error state or you can simply call it as D or Q0, Q1, Q2, Q3 does not matter. You understand everyone? Everyone clear? No doubts, huh?
So that's the final answer.
Yes, this is the final answer. There's no intermediate answer. So this is a DFA, eh? I've changed it. 1C, it's no more 1C now. It becomes 2C. Yeah. As it works for every state, maybe you can do a research. I don't know. I haven't checked that. Okay. I don't know. I cannot say yes without verifying it. I don't know. I never thought it in that. Plus one with minimum number of. The minimum length for this is only one. Here 777, yes. But here the minimum number is just 160. Yeah, here also. Here the smallest possible string is here, 1C. The smallest possible string can be just one digit. I've given here. It can be one digit or two digit. Only here the smallest possible string is 3 letters. Here also 3 letters because it's 3 ones. It's 777, so 3. Here it just says do not contain 777. So your valid string is 1 digit, 2 digit, 3 digit, 4 digit, any number of digits as far as it does not have the 777. So here again your thing is here the length is 5 or less. So it can be 1 digit, 2 digit, 3 digit, 4 digit, 5 digit. Your string here can be 1 digit. You can just have 0. What is the answer we saw? We saw that every state is a final state, right? Yeah. So you can have simply 1 digit, 2 digit, 3 digit, 4 digit. Maximum is 5 digit. Have length 5 or less. So maximum is 5. Here the maximum is 5. Here the maximum is infinity. Here the maximum also infinity. Here the maximum also infinity. Now he is putting a theory. The number of states depends on the minimum length of the valid string plus 1. Okay? It appears to be coincidental. How in the sense? Here it may be coincidental because the minimum smallest possible valid string is 3 letters, 777. Here also the smallest valid string is 3 letters, 111. Okay? But here the smallest possible string is only 1 digit. Here also smallest possible is 1 digit. What is the maximum length of the string here? Valid string, infinity, 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 infinity. You can have a valid string infinity, no. Okay? Yeah.
One correction. If it is a substring, then
Sorry?
only substring works only for substrings which have a substring.
Every question has a substring.
Yeah. No, I mean for the one that is used to contain a substring.
No, okay, we will discuss offline. Yeah, because I don't want the others to be distracted. No, every string here, see, when you say 7, this actually is a substring as well.
No, I mean when it specifies in the question that it supposed to be a substring.
But we don't have a substring here.
The second one.
Yeah, 777 is a substring, yeah. We can purely have 777.
Yeah, but the number of states will be 4.
No, that theory doesn't apply. Your theory doesn't apply. You try for every machine that comes to you. You can write a paper. This is paper. Okay, let's go to. That's why I said we can take it offline because that is not related to the subject exam or test. Yeah. Later, when we have time, I will come to his argument because he may feel bad. I am not discussing his argument. I will. Okay. The only thing is I don't have a time. because it's already 12:50. I need to finish this. Okay? Because a week after next week is your break week, right? Yeah, but not break week, it's a mid semester, they call it as independent learning week. Okay? And today I had a challenge. That's why I didn't email you. I told you I will replace this Thursday's class Saturday, right? Online. The school said I cannot replace by online, it has to be face to face. Okay? So I'm not bringing you this Thursday. Again, I'm reminding you. I will send a message to my times. This Thursday, our class is postponed. Meaning cancelled. This Thursday cancelled. It will be replaced on another day. But I need to discuss with you because last Thursday, I remember when I asked in class, after 7 to 8, they said they have another class. Okay. So I have to ask them because we have many batches. I have to ask in the class. Find the common slot when everyone is free. Okay. So the school said I thought I can replace it online on a Saturday. Okay. They said cannot. So if a class is postponed or cancelled, it has to be replaced physically. So now I'm stuck now. So I have to wait until next Thursday because I see only a small class here. So with you, I cannot decide on which date I can replace my Thursday's class because the lecture class. Okay? Yeah. So we need to finish this because otherwise your test will get delayed. Because this week is 6th week, next week is 7th week. I have to find out next week and replace it next week itself. Okay? So I'm telling you this Thursday, no class, lecture class. I will replace it physically before you go for the independent. Don't worry, it's my problem, I'll do it. Okay? So let's go to question number 3. Question number 3 says construct an NFA for each of the following language given below. So question number 3 just says to construct an NFA. It doesn't ask for DFA. But if you want to learn, you can try to do the DFA as well. Okay. So the question says set of strings over A or B or C. So up to here, what it means is the alphabets are simply A or B or C. Okay. Up to here, this language uses alphabets A or B or C now. And then it follows in which all the A's, so A's means one or more A's. Okay, one or more A's. So to me, the smallest possible string, in which all the A's precedes means appears before. So I know some of you have challenge understanding what's it between precedes and succeeds. Precede means appear before, succeed means follows after. Okay? So all A's precedes the B's, which in turn precedes the C's. So this is my smallest possible string. Okay? This is my smallest possible string. So A appears before the B's and B appears before the C's. In which all the A's precedes the B's, which in turn precedes the C's. Okay? Smallest possible string. Okay? I can have something like this also. The number of A's, B's and C's need not be equal. That's what I stress this. A's means it's not plural, apples, no. One or more A's. B's means one or more B's. Okay? In English, more than one, two or more is plural. Okay? Plural, singular, plural. One means singular, two or more is plural. But here, when we say A apostrophe S, it's not plural. It means one or more A, one or more B, one or more C. Okay? So that's why I'm having one A followed by one B followed by one C. If you look at here, one or more A followed by one or more B followed by one or more C. Okay? Can I have something like this?
No.
Wait.
AC. Yeah. All A's precedes into. If the A precedes the B, which precedes the C, that means A precedes the C.
I don't know. Let me quickly share the camps. Very 5 minutes. Then we can continue.